Hi friends, welcome to another episode of Declutter. In today's episode, let's look at this mind-blowing problem that I came across while preparing for my JEE. Now this problem is from one of the most beautifully written maths book by KD Joshi. Take a couple of minutes to first understand the question. I have made it a little simpler with an image. Try solving it. If you don't get the solution, come back to the video for the solution. Let's go through the question together. So the question states that there is a regular hexagon standing on the ground. Not in this fashion. The hexagon is standing on one of the bases. A cat jumps such that it grazes the top four corners. This part, top four corners, helps us understand that the hexagon is standing on one of the bases and not on the vertex, and lands back on the ground. What is the ratio of the speed as it touches the ground to its maximum speed? Now, as a hint, this question uses concepts of quadratic equation, progression, sequences and series, and some bit of physics from motion in two dimension, because if you are not able to do motion in two dimension, you will definitely not understand what this question is all about. Another hint, this question is from the topic heights and distances, which is a part of trigonometry. So what I'm trying to say is this question is a mix of quadratic equations, sequences and series, trigonometry, and a bit of motion in two dimension. Let's see how the solution to this question works. I have taken a regular hexagon of side length 2a on the ground, and a particle is projected from this point such that it is simply grazing the top four corners. If the particle is projected with a speed of u making an angle alpha, we know that the minimum speed occurs at point P and is given by u cos alpha, and the speed as it touches the ground again is the same as u. So when they're asking the ratio of this to this, they're essentially asking what the value of 1 by cos alpha is, which is equal to secant alpha, and that's about where the visualization with physics ends and what starts is a use of math. Let's look at where else we apply physics in this question. We know that the vertical displacement is given by the initial velocity in the y direction minus half gt square, and the horizontal displacement is given by u cos alpha into t. Let's take the time it reaches at A1 is T1, T2, T3, T4 and T5, where T3 corresponds to the highest point. Since it is a regular hexagon, I know that each of these distances is going to be A from symmetry, and from trigonometry we know that this is root 3a. Since the equation of sy is a quadratic, what it means is for a certain height, there are two times when a particle reaches that point. So if I substitute the height as 2 root 3a, I will get two values of time which correspond to t2 and t4. Same way, if I substitute root 3a as the height of a and b, I'll get two solutions to this which correspond to t5 and t1. Now, we know that in the horizontal or the x direction, we have non-accelerated motion. So I can simply say that u cos alpha into t5 minus t1 is this distance, which is equal to 4a, and u cos alpha into t4 minus t2 is 2a, which is the distance between BC, right? Now, if we have a quadratic ax square plus bx plus c equal to 0, we know that the sum of the roots alpha plus beta is minus b by a, and the product of the roots alpha beta is c by a. If we have to find alpha minus beta, we can actually, using identities, prove it to be equal to this, which in turn is equal to b square minus 4ac by a square. And I'm going to use this in this equation. I know that the differences of time, if I look at points A and D, the differences of the time there are T5 minus T1 corresponds to A and D, and T4 minus T2 corresponds to B and C. So if I write the difference of time, I will get the equation as u square sine square alpha minus 2g into sy divided by half g square. So I know T5 minus T1 as u square sine square alpha minus 2g, and T5 and T1 are obtained at a height of root 3a divided by half g whole square, and this is equal to root of u square sine square alpha minus 4 root 3 ag, because the sy at that point is 2 root 3a divided by half g square. I also know that T5 minus T1 is 4a by u cos alpha from the x direction, and T4 minus T2 is 2a by u cos alpha. Using these equations, if I simply equate, let me call this 1, 2, 3 and 4. By equating 1 and 3, I have u square sine square alpha minus 2 root 3 ag by half g square under root is equal to 4a by u cos alpha, and equating 2 and 4, I have root of u square sine square alpha minus 4 root 3 ag by half g square is equal to 2a by u cos alpha. To make our calculation simpler, I am not going to square it and do all that stuff. I am simply going to divide both of these, because then my only variable is a u sine alpha, the u cos alpha, and a lot of stuff get cancelled. So when I divide this with this, I have root of u square sine square alpha minus 2 root 3 ag divided by u square sine square alpha minus 4 root 3 ag is equal to 2. And when I square, I will get u square sine square alpha minus 2 root 3 ag is equal to 4 into u square sine square alpha minus 4 root 3 ag. So this will finally give you 3u square sine square alpha is equal to 14 root 3 ag. And this is my first equation. What I'm going to do with this equation is, again, substitute u square sine square alpha in equation number 1 or equation number x to get the value of u cos alpha. So I have equation x as u square sine square alpha minus 2 root 3 ag by half g whole square is equal to 4a by u cos alpha. Plugging in this value of u, so when I square this, I will get u square cos square alpha is 2ag by into 2, because I've squared it, but this a square g square I've cancelled with 1 ag, divided by into 3 divided by 8 root 3 a square, which is equal to 3 by root 3 ag into 2. Now, if I take this u square cos square alpha and u square sin square alpha is 14 root 3 ag by 3, which is equal to 14 ag by root 3. If I divide u square sin square alpha with u square cos square alpha, what I will get is tan square alpha is 14, the 2 in the denominator multiplies and becomes 28 by 3. Now, if I simply do 1 plus tan square alpha is secant square alpha, that will give me secant square alpha is 31 by 3, and the answer to our question is root of 31 by 3, because they have asked the value of 1 by cos alpha, which is secant alpha. Now, this question involved a lot of calculations and manipulations. The trick and the catch here was, instead of squaring these and getting very dirty looking equations in sine square and cos square, I just used the property of ratios to simplify my calculation. I hope you found this video interesting. If you did, do like, share and subscribe to our channel. Thank you.